So guys, this is the sensor here. As you can see, that is the LED. See, the bubble is in the center. I rotate it. See, I tilt it and the LED turned on. This means the tilt has been detected. Again, I bring it in the sensor. The tilt is gone. See, again I rotate it. The bubble, now take a look at this bubble. This bubble over here is now no longer in the center. Now again I bring it to the center. See, the bubble is in the center and the tilt is gone. Now again I tilt it to the right. See, the tilt has been detected. It's simple as that. Let me show you the code in a quick way. See, let me zoom in. So guys, this over here that we initialize the sensor pin, and this we initialize the LED. Then we check if the tilt is detected. If it's detected, we wait for 50 milliseconds, and once it's still there, then we consider that tilt is detected. And then once the tilt is detected, the LED is turned on, and else the LED is off. Simple as that. Hello guys, welcome back to learning microcontrollers. In this video, I will show you how we can interface a mercury tilt switch module KY-017 with PIC16F877A microcontroller. So let's get started. So guys, this is our keys KY-017 mercury ball tilt sensor. As you can see here, we have a ball inside it. So once the sensor is tilted, the ball will go to the other side, and at that time it will trigger a signal, and through this signal pin the signal will go to any input device. You can use a microcontroller, FPGA, or directly to any relay or whatever you prefer. So this works in this way that whenever there is a tilt, like you tilt it, this ball will go to that end like a ball in water or something, a bubble in the water. It works like a bubble, and as soon as the tilt is detected, it will slide to the other side, causing the switch to operate. So simple, it is very simple to use. It has only 3 pins, as you can see. So the pin towards me on which S is mentioned, this side where S is written, is the out pin. That's a digital input output or a digital output signal pin, not input, only output pin. For the microcontroller, it's an input. For the sensor, it will be the output pin. And the center one is the VCC, that is the 5-volt pin. You can give maximum of 5 volt to this module. And then the top one, if you hold it like this, is a ground pin, and here the symbol minus is mentioned. Now guys, as you can see, you can see that. Now let's connect it with a PIC16F877A. This is our PIC16F877A microcontroller having 40 pins. It's a DIP version. Let me relabel this module for you. The left one where S is written, that is the signal pin, output pin for the sensor and input pin for the microcontroller. The center one is the VCC and the right one is the ground pin. Now guys, connect the VCC pin directly with the VCC of the PIC. So 5 volt will go to the PIC, and 5 volt from the PIC will come to this module as well, and ground will go to the ground of the PIC. So whichever source is powering up the PIC with 5 volt will also power up the module. And then for the output pin, you can use any digital input output or a GPIO pin of your PIC16F877A microcontroller. I'm going to use the pin number D2 for this. Now guys, for the output, to display the output, I'm going to use a LED. Whenever the sensor is operated, we will program the PIC16F877A in such a way that whenever the tilt is detected, an LED on the PIC will turn on, but as soon as the tilt is gone, the LED will turn off. Simple as that, just for the demonstration purpose. So for that purpose, this is a 5 mm LED, easily available in the market, and it has 2 pins, one longer, one shorter. The longer one is the power and shorter one is always the ground pin. And then guys, to connect it with the PIC, I will need a 220 ohm resistor. It's a safety resistor. So any value between 100 and 500 will do. You can go for the higher values as well, but higher the value, the dimmer the LED will go. So 220 ohm is an ideal value for this LED. So guys, I will connect the power pin, that is the longer pin of the LED, with one end of the 220 ohm resistor like this. Then from the other end of this 220 ohm resistor, connected to any available digital input output pin of your PIC, I am going to use a pin number D3 like this. Then for the ground pin of the LED, just connect it to the common ground of the PIC like this. Now guys, in this way our circuit is completed. Now we will move on to the programming, and before we move on to the programming, let me introduce you to the hardware. So guys, this over here is the hardware. This one is the LED I am going to use, and behind you can see is our PIC16F877A microcontroller, and PIC 3.5 is there. I am going to use it for the programming purpose, and this rest is just a trainer board. And I have a video on that, how you can set up your hardware. I will share the link to that video in the description as well. So guys, first of all, before we move on, let me show you how this sensor works. So you can see that if you take a close look, in the glass bottle, you can see a bubble. See, when I tilt it, I had just twisted this LED, this glass bottle, sorry, to the right. So, whenever I will tilt it to the in this direction, it will be bubble will be in the down, causing the switch to operate, and in this way a tilt will be detected. So, I will use this mercury ball module as a tilt sensor here. See, I tilt it to the right, the ball goes to the right and the tilt will be detected, and then we will program the PIC in such a way that once the ball is to the right, this LED will turn on, showing that the tilt has been detected. And once the sensor is back in the center like this, see the ball moves in the other direction, see the ball in the glass. Now, it will show that the tilt is gone and again the sensor is in the center position. Now, guys, let us move on to the programming. So, let me turn on. So, guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. And this is MikroC for PIC version 7.2.0. I have a video on that, how you can download and install this compiler software for free. I will share the link to that video in the description as well. Click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. Mercury Tilt Switch Tutorial by Learning Microcontrollers. Simple as that. That's the name I wrote. Select the path where your files will be created. Select the microcontroller you are going to use. I am going to use the PIC16F877A. Select the crystal that is connected to the pin number 13 and 14 of your PIC16F877A, and that crystal in my case is 20 megahertz. So, I write 20 here. Click on Next and Finish. Now, guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S. This window pops up, select the path and save your work. Now, guys, the next thing is, first of all, as shown in the presentation here, we have here two LEDs, two pins only in use. One is for the LED, that is D3, and D2 is for the sensor. So, we initialize both the pins. So, first of all, I initialize the sensor pin, trace D dot F2 equals to 1. See, 1 means the pin has been declared as input, and 0 means it is output, and trace is the direction register. Now, guys, the next thing is, initial state is not required because its sensor just gives some initialization delay. Not necessary, but I always suggest you give the initialization in one-time loop. Now, this is our sensor is initialized as input, sensor pin is initialized as input. Now, we initialize the other pin, and the other pin is the LED pin, and that is pin number D3. See, its LED is connected to pin number D3. So, let us go back to the programming and write down trace D dot F3 equals to 0. Now, see the difference here. As I told you earlier, trace is a direction register. 1 means its input, the pin has been declared as input. In case of Arduino, it's like a pin mode input and output, and in case of MikroC, it's a trace register. So, 1 means it's input and 0 means it's an output. Now, here the LED is always connected to an output pin, and output is taken as 0. And by default, the LED must be off. So, we write here port D dot F3 equals to 0. So, by default, the LED will be off. Now, give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. Now, guys, we move on to our forever loop. We have our LED initialized and we have our sensor initialized. So, write down while 1, forever loop starts here and ends here, and make it look presentable. Remove these spaces like this. Now, guys, first of all, we will need to read the sensor, that if port D dot F2, that is the sensor pin, double equals to 1, if the tilt is detected, then what it should do? It should detect the tilt again. Why? Because there is a problem that the tilt is accidentally detected and the time was not enough. Like accidentally the bubble moves here or there and tilt is detected. So, we give some delay like this, that if the tilt is detected, then it should wait, like for any time that you want to set. I set it to 50 milliseconds. Wait for 50 milliseconds. If still the tilt is there, now again detect the tilt. Now, again, even after 50 milliseconds the tilt is there, then it will consider that the tilt has been detected, and give the ending bracket to both the loops like this. So, just in case of a button, it's like a debounce. So, here too we are using debounce as well, same concept. See that here. Now, if the button is, if the tilt is detected, it will wait for 50 milliseconds. If still the tilt is there, only then it will consider that the tilt has been detected, and once the tilt is detected, it will turn on this LED, which is off by default. The LED at pin number D dot F3 will become 1. and we should keep it 1 for some time, and for like 100 millisecond it will remain 1. Now guys, if and in other case if there is no tilt, then the LED will go off, else the LED is off. Just make it 0 like this, and also give it some time here, not necessary, but you give it to like 20 millisecond. So the programming is very simple. It will detect if the sensor has given the output signal that a tilt has been detected, then it waits for 50 millisecond. If still the tilt is there, only then it considers the tilt has been detected, and then it performs the operation as programmed, that it turns on the LED, and then if there is no tilt, then the LED will remain off like this. It will go back to the initial state, this state. Now guys, let me burn this to the microcontroller and see what happens. Go to the PIC16 programmer tool. I have a video on this as well, how to download, install and use this. I will share the link to that video in the description as well. So first of all, you select the microcontroller from here. We are using PIC16F877A, this one. Select it, go to the file, import hex file, and look for the file you just created. Okay, we forgot to click on build. Once the file is done, you have to click on this build button. See, it's built without any error. If there was any error, this was to show error. Now go back, go to file, import hex file. Here it is. Now the hex file is built. Double click on it and click on write. Okay, it is being written. Let's get to the hardware and see what happens. So this is the hardware. Let it build the new file. Okay, the file is built, burned. Now I power up the circuit using this on button. This means the PIC3 will power up the circuit. I click on. Okay, the circuit is powered up. So that's great. The bubble is in the center and the LED is off. Now I move the bubble to the right. See, the LED turns on. This means the tilt has been detected. Now I again bring the bubble to the center. See, it means the tilt is not detected. It's 0. The PIC is reading 0. Now the tilt has been detected. Again in the center, see that it's in the center, no tilt. At right, the tilt has been detected, so the LED turns on. Again I bring it to the center, the bubble is in the center, no tilt. Now I go to the right, the tilt has been detected and the LED is on. So guys, it is simple as that. If you guys have any questions, you can ask me in the comments, and thank you very much for your time, and I will be very glad to know that you guys learned something from this video. So guys, thank you very much for your time and have a nice day. We'll see you in the next video.